Hello there once again and welcome back to our Chem 152 video series. In this video we'll go over an electrolysis problem. The question says if you pass a 2 amp current through a sample of Al3+ solution, how long would it take to deposit 1 gram of aluminum metal? To find how long it would take to deposit a certain amount of metal, we start by saying NF equals IT. And we'll go over what all symbols mean. N will be our moles of electrons. F will be Faraday's constant. I will be our current. And T will be our time in seconds. Since the question is asking how long it will take to deposit that means our unknown here will be time, and we'll have to try to find the other 3 letters. Now, our current is also given in this problem as 2 amps, which means we know the I, that's the current. Faraday's constant is always the same number, 96,485. That means we know F. However, N is a little bit more troublesome. We need to look at the reaction that's taking place and figure out how many moles of electrons are changing hands. In this question, we are given Al3+. And we're also given that it will become Al metal, meaning you'll change this to Al0 with no charge. You don't have to write the 0, but I'm going to do it this time for clarity. Now, if we look at the charges, we've gone from 3 positive down to 0, and this is a change of 3 electrons. As in a previous example, we'll add those 3 electrons to the side that is higher charge. That is the 3+ side on the left. We'll put 3 electrons on the left. However, it's not enough to say that there are 3 moles of electrons. We have to take into account how much aluminum metal we have. I'll make a note just for clarity that the moles of electrons are not just 3. Instead, we're going to do stoichiometry. We're going to start from our grams of aluminum, change this to moles of aluminum, and change that to moles of electrons. This means we'll have a 2-step conversion. We'll start with 1 gram of aluminum metal. We'll get out of grams and into moles. We can use the molar mass of 26.98 next to grams and 1 next to moles of aluminum. Then we'll get out of moles of aluminum and get into moles of electrons. The balanced equation says for every 1 mole of aluminum, we have 3 moles of electrons. Then we'll go to a calculator and multiply all this together. We'll end up with 0.111 moles of electrons. Now that we know that the current is 2 and we know our moles of electrons are 0.111, we can do the algebra to try to find time in seconds. For our algebra, we can divide both sides by I. And so time will equal N times F over I. Our N was 0.111, our F was 96485, and then our current is 2 amperes. Then we can go straight to a calculator, and this will give us our time in seconds. We'll end up with approximately 5364 seconds. If you wanted to change this to hours, you could divide this by 3600. Seconds in 1 hour, you will end up with 1.49 hours. Therefore, after 1.49 hours, you would have approximately 1 gram of aluminum plated out. Thank you for watching, and we'll see you again soon.